Welcome. Today we're diving deep into advanced Kotlin functions and scoping. If you've ever wondered how let, apply, also, run, and with differ, or how generics and type inference work in Kotlin, you're in the right place. We'll break down each function, compare their behaviors, and see how they're used in real-world scenarios. By the end, you'll have a clear understanding of how to write more expressive, safer, and cleaner Kotlin code. Let's start by exploring the core differences between these essential scope functions. Let function in Kotlin is a scope function that executes a block of code only if the object is non-null. Inside let, the object is referenced as it, but you can rename it for clarity. The function returns the result of the lambda, not the object itself. This makes let perfect for transforming data or handling nullability in a concise way. For example, you might use let to map a value or perform an operation only if a variable isn't null, avoiding unnecessary null checks throughout your code. Apply function is designed for configuring an object. Inside apply, the object is referenced as this, and you can even omit it for brevity. The key feature of apply is that it returns the object itself, making it ideal for object initialization or property configuration. For instance, when creating a new instance and setting multiple properties, apply keeps your code clean and avoids repetitive references to the object. It's like customizing a car and getting the upgraded version back. Also, function is all about performing side effects without altering the object itself. Like let, it references the object as it, but it returns the object, not the lambda result. This makes also perfect for tasks like logging, validation, or debugging, anything you want to do alongside your main logic without changing the object. Think of it as taking a photo of your car for insurance before you drive away. You still have the same car, but now you have a record. Run function combines object configuration and computation. Inside run, the object is referenced as this, and the function returns the result of the lambda. This is useful when you want to configure an object and immediately compute a final value based on its state. For example, you might set up a profile and then return a summary string. Run is flexible and can be used for both object setup and returning custom results. With function is a little different. It's not an extension function, but takes the object as an argument. Inside with the object is referenced as this, and the function returns the lambda result. With is great for grouping multiple method calls on a single object, making your code more readable and organized. Imagine you're working with a document and want to perform several operations in sequence, which lets you do this cleanly, all within one block. Now that we've introduced each scope function, let's compare them side by side. The main differences are how they reference the object, either as this or it, and what they return, either the object itself or the lambda result. These distinctions help you choose the right function for your use case, whether you're transforming data, configuring objects, or performing side effects. Understanding these differences is key to writing idiomatic Kotlin. Make these concepts more relatable. Imagine a car. Using apply is like installing a spoiler and tinting the windows, you get the upgraded car back. Using also is like taking a photo for insurance. You still have the same car, but now you have a record. Using let is like looking up the license plate. You get a string back, not the car. These analogies help clarify when to use each scope function in your Kotlin projects. Let's look at a practical example using a car data class. We'll use apply to set the car's color and speed, also to log its properties, and let to transform or handle nullability. This approach keeps your code concise and expressive, avoiding unnecessary variables and making your intentions clear. Scope functions are powerful tools for writing clean, readable Kotlin code. Scope function chaining lets you link multiple scope functions together in a single fluid pipeline. This means you can initialize an object, perform a side effect, and transform data sequentially without creating extra variables. It's like an assembly line in a factory, where each step builds on the previous one. This technique makes your code more readable and efficient. Imagine a smartphone assembly line. First, apply attaches the battery, then also scans the barcode for logging. Finally, let boxes the phone and attaches a shipping label, converting it into a shippable parcel. Each scope function plays a distinct role, and chaining them together streamlines the process, just like in a real-world factory. Here's a Kotlin example, sanitizing an email input. First, let trims the input if it's not null, then also logs the raw value. Finally, lowercase transforms the string. If the input is null, a default email is returned. This chain avoids intermediate variables and keeps the logic clear and concise. This keyword refers to the current object instance inside a class method or scope function like apply, run, or with. If you have nested scopes, this always refers to the innermost scope unless you use a qualified label. This helps avoid confusion and makes your code more explicit, especially in complex scenarios. Think of this like saying my home or standing inside your house. If you're in the living room, my TV means the living room TV. If you step outside to a town hall, you'd need to say my house's TV to be clear. In Kotlin, qualified this works the same way, helping you reference the correct instance. See this in action. In a user class, this refers to the user instance. Inside a run block, this refers to the string being processed. To access the outer user, you use a qualified this, like this at user. This makes your code precise and avoids accidental mistakes when working with nested scopes. In Kotlin, if a lambda expression has exactly one parameter, you don't need to name it explicitly. Kotlin automatically provides an implicit variable called it to represent that parameter. This makes your code shorter and more readable, especially in common operations like mapping or filtering collections. Using it is like using pronouns in conversation. Instead of repeating the book every time you say pick it up, open it, read it. Kotlin's it works the same way, letting you write concise and natural code when working with single-parameter lambdas. For example, when mapping a list of numbers, you can write numbers.map it to instead of naming the parameter explicitly. This keeps your code clean and focused on the transformation, not on variable names. By default, an unlabeled return statement exits the nearest enclosing function, not just the lambda expression. Labeled returns let you break out of a specific lambda or loop without terminating the entire outer function. This gives you more control over flow, especially in high-order functions. Imagine an audit inspector visiting stores. If they find an error in store 3, an unlabeled return means they quit their job entirely. A labeled return means they simply skip store 3 and continue with store 4. In Kotlin, labeled returns let you control exactly where you exit. Here's a code example, looping through a list. If you encounter stop, a labeled return skips that item and continues processing the rest. This is especially useful in for each and other high-order functions, ensuring your code behaves as expected. Generics in Kotlin let you write reusable code that works with different data types while preserving type safety. You define generics using angle brackets, like T, where T is a placeholder for any type. This makes your code flexible and robust, reducing duplication and errors. Think of generics like a shipping box. You don't build separate trucks for every type of item. Instead, you have a generic box T that can securely transport any item type. This analogy shows how generics make your code more adaptable and efficient. For example, you can define a generic class storage box T that holds any type of item. You can then create storage box int for integers or storage box string for strings. This approach keeps your code dry and type-safe, letting the compiler catch errors early. You can also write generic functions like print element T, which prints any type of element. The compiler infers the type based on the argument you pass, making your functions flexible and reusable across different data types. Variance in Kotlin generics is handled by the in and out keywords. Out or covariance means a generic class can only produce or return type T, making it read-only. In or contravariance means a generic class can only consume type T, making it write-only. These rules help manage subtyping relationships safely. Imagine out as a vending machine that dispenses fruit. It's safe to get any kind of fruit out. In is like a trash bin for plastic. It can safely accept any subtype of plastic. These analogies help clarify how in and out control what types you can safely use in your code. For example, a producer out T can only produce items of type T, not consume them. This means you can safely assign a producer apple to a producer fruit, since apples are fruits. This rule prevents unsafe operations and keeps your code type safe. Consumer in T can only consume items of type T, not produce them. This means you can assign a consumer fruit to a consumer apple, since a general fruit consumer can handle apples. Contravariance ensures you don't accidentally use types in unsafe ways. Kotlin's compiler is smart. It can automatically deduce the data type of an expression based on its context and value. This feature, called type inference, saves you from writing out type declarations by hand, making your code cleaner and less error-prone. Think of type inference like seeing a glass filled with ice cubes melting into water. You don't need a label to know it's ice. Your brain infers it from context. Kotlin's compiler works the same way, figuring out types based on how you use them. For example, when you write val message equals hello world, the compiler knows message is a string. If you write val current year equals 2026, it knows current year is an int. This reduces boilerplate and helps you focus on logic, not syntax. Normally, Java and Kotlin erase generic type information at runtime, so list string and list int look the same to the JVM. By using an inline function with the reified keyword, you can preserve the actual type at runtime, allowing you to check types directly. Think of reified types like a temporary tattoo stencil. Instead of carrying a heavy stamp, you apply the stencil and paint directly on the skin. The final artwork stays at that spot. Similarly, reified types let you keep type information right where you need it at runtime. Here's a Kotlin example. An inline fun reified t-check type value any lets you check if value is of type t at runtime. Without reified, this would cause a compiler error. With reified, you can safely perform type checks and write more dynamic, type-safe code. Typealias in Kotlin provides an alternative, cleaner name for an existing, complex, or long type signature. It doesn't create a new type, but acts as a shortcut, improving code readability and maintainability, especially in large projects. Think of typealias like setting up a speed dial or nickname on your phone. Instead of typing out a long contact name every time, you assign a shortcut. In Kotlin, typealias lets you do the same for complex type signatures, making your code easier to read. For example, you can define typealias user registry equals hash map string, list map string any. Now, instead of writing the full type everywhere, you just use user registry. This makes your code much more manageable, especially when working with complex data structures. Typealias isn't just for data structures, you can also use it for function types. For example, typealias auth callback equals is success, boolean, error message, string. Unit makes callback signatures much cleaner and easier to use throughout your codebase. Recap Kotlin's scope functions, let apply also run, and with each serve a unique purpose. Understanding their differences helps you write more expressive, concise, and safe code. Whether you're transforming data, configuring objects, or chaining operations, there's a scope function for every scenario. Generics make your code flexible and reusable, while variance with in and out ensures type safety. Type inference reduces boilerplate, and reified types let you keep type information at runtime. Typealias makes complex code more readable. Together, these features make Kotlin a powerful language for modern development. In working with Kotlin, choose the right scope function for your task, use generics to avoid duplication, and take advantage of type inference for cleaner code. Use typealias to simplify complex signatures, and remember to use labeled returns for precise control in higher-order functions. Be careful not to confuse which scope function returns what or how they reference the object. Misusing in and out in generics can lead to type errors. Always check if you need a labeled return in high-order functions to avoid unexpected behavior. Stick to best practices. Use let for null checks and transformations, apply for object configuration, also for side effects, run for combined setup and computation, and with for grouping calls. Use generics and typealias to keep your codebase clean and maintainable. Congratulations, you now have a solid grasp of advanced Kotlin functions and scoping. With these tools, you can write safer, cleaner, and more expressive code. Keep practicing, explore more real-world examples, and you'll become a Kotlin pro in no time. Thanks for watching, and happy coding.